All right, so today we are going to take a look at division, of course, but this time it's going to be using base 10 blocks. So we have our 2-digit by 1-digit example here, 12 divided by 2. Just a reminder that in division, we call the whole or the total that we have to share up the dividend, and the equal number of groups or the number of groups we have to share it up into the divisor. And the answer, though the total inside of each group, which must be equal, is called the quotient. All right, so here we have 12 divided by 2, and I have shown it in its number bond diagram. All right, so therefore we have 2 multiplied by something to get 12. Now multiplication is the inverse of division. That's why we have to think about it as well as what must we multiply by 2 to get 12. Yeah? So let us take a look at what 12 would look like using base 10 blocks. Now, in the case of, let's say, you have to draw this out, we can just simply substitute the blocks itself for a particular color. So let's say I wanted to have my 10 in one color and my ones in another color. I can do that. Yes? So I'm going to have my 10 in yellow. 12 is made up of 1 10. I'll use red for my ones and 2 ones, right? So 12, we have 1 10 and 2 ones. Now I'm going to draw the number of groups that I have to split this into. My divisor is 2, therefore I have 2 groups, and in each group I must have an equal number. So when I look at my tens place digit, I only have 1 block here, just one of these. And I cannot share this up into these 2 groups. I might have to break it in half, but we're not there yet, right? So if we go back to our place value understanding, we know that 110 is the same as or is equivalent to or is equal to 10 ones. It will take 10 ones to make up 110. So I'm just going to take this, I'll leave this here actually, and I'm going to draw. I'm going to draw an arrow that symbolizes or shows regrouping, right? Regrouping. Don't mind my handwriting there. And then I'm going to take 10 of these ones. And of course, ones can't be in the tens place. All right, so we have to put them in the ones place. Let's see. I hope you're counting. We need how many more? We need 2 more here. So our new, well, the number is not new. The number is the same, right? I'm going to cross my 10 to show that regrouping occurred here. So I still have 12. My value is still 12. However, it's now 12 ones instead of 1 10 and 2 ones. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to split this up. I have enough. 12 is more than 2. So I can definitely split this up. 1 was not more than 2. It was less than 2. So I couldn't split it up. Now I can, which I am going to do. All right. And of course, if you know your 2 times tables, you will already know what your quotient will be here. And we could already fill in that missing number in our number bond here. So if you check, you have 2, 4, 6, 6 ones, Here we have 6 ones here. Are they equal? Yes, they are. So our missing number in this bond was 6. 2 times 6 is equal to 12. And that's how we check. We use the inverse operation to check. 2 times 6 is equal to 12. Right? 12 divided by 2 is equal to 6. So that is our first example of 2 digits by 1 digit division. All right, and this showed regrouping instantly. I'm also going to show how it would happen without regrouping needing to take place instantly. In this case, it was instant because 110 was less than 2. We could not split that up into 2. All right.